Hello, everyone. Welcome to another session of the Chainlink Hackathon. Good to see everyone. Really excited to have Rodek here from QuickNode, and he's going to be sharing with us a lot of cool information. So if you have questions, definitely drop them into the chat. And yeah, Radek, I'll let you take it away.
Yeah, hi, hello here. Nice to see everybody. Nice to run this workshop. Just maybe first introduction. I'm Radek. I'm a developer advocate at QuickNode, and we'll be doing an action-packed workshop in the nearest hour. And my question is, do we have like 60 minutes and that's it, or if we need to go over a few minutes, is it possible? What's the plan here? I want to know how strict I need to be with everything.
Yeah, we would like to keep it about at that 60 minutes, but if you need to go a little over, that's okay as well.
Okay, cool. I'll try to be brief where I can and to take a few shortcuts then, but the goal is to go from zero to a live NFT collection on OpenSea on testnet with an ability to mint. Great. So let's see the code. How do I switch to my screen? Oh, okay. Cool. So this is, I'll try, as always, try to make everything as large as possible. So this is the repository with the code that will have everything. Later on, I will add the link in comments. Actually, maybe I'll try it now. Yeah. So the link should be in the comments in a few seconds. Everything should be here after the workshop. So we are starting with like more or less like scaffold, where the hard hat file is configured for you, where there's an empty contract which we can start working with and start filling out, but we need to actually write it. That's the whole idea and the premise of this workshop. But to make your life easier, this is like a starting point, and you can clone it. After the workshop, I will add also the full file that we will be writing during the workshop, so that you will have also the end result, and you'll be able to take it and start playing with it and start taking it to next steps. So what are we building? We are going to create a aptly named Balls of Art NFT collection. This is more or less how it is going to look like. It's a single NFT is going to be like that, and everything here is randomly generated, or everything as much as possible. So the background color is randomly generated. The size of each ball, it could be 3x, 2x, or 1x. Then the color of the ball, and also one of the balls will have the smiley and the eyes, and it will be animated as well, which is also randomly selected which one. So that's what we are building, and this is a sample collection on a OpenSea testnet with a few already minted. So this is what we can expect. And as you can see, randomly generated different kinds of backgrounds, balls, colors, and so on. So this is what we want. We want these balls of art live on testnet. And this is what we are going to build. Now, what else? What's the purpose of this? The purpose of this. Did I just close my? No. Yeah, let this. Okay. The repository. So the purpose of this is a few actually. So what I want to do is I want to show how to structure an NFT project, how to pseudo randomize different elements. And because we only have 1 hour, I will not be using Chainlink oracles, but I think this would be the very next step, to use Chainlink oracles to have like truly random numbers. And I will tell you and show you where and when and how to do it. Then how to draw simple SVGs, because that's what it's going to be. This is not an image that you create in Photoshop or wherever else. This is all generated by code that we are going to write very quickly. And also how to start playing with SVG animation so that you can start playing with it and then create more and more complex generative art with this as step one. So that's the purpose of it. That's what we want to achieve. And this is an end result after 1 hour. Then it's all up to you what your imagination, where it will take you. So let's start and found the repository that we are looking at. So we are cloning the repository into the Balls of Art tutorial folder. Now we are going into this folder, and now let's open. Let's open the code. Now we won't need this anymore. Okay, so let's make it, as always, as large as possible. Now, first, what we need to do is to start installing all the dependencies from this, so that we can start working. We already have the scaffold. Okay, dependencies are installed. And the contract is there. It's a quite empty one. We need to fill it out. Now, if we want to later on at the end deploy it to testnet, we will need a few more elements. We will need an RPC node so that we can connect to blockchain and actually deploy that contract, read and write to blockchain. We'll need a private key of one of the wallets, because some wallet will need to actually deploy that contract and pay ETH or test ETH for that contract. So we need private key for that. And also we'll need Etherscan API key in order to verify the contract, so that the contract source is on Etherscan, because we will not have enough time to write front end for our NFT collection. So we will not be able to mint on a nicely designed page and with nice minting experience. We will be minting, connecting directly to blockchain on Etherscan and running the minting function through Etherscan. And that's why we need to verify the code so that we can do it. So in order to do that, we need to copy paste. We need to have an env file, and you can get a free RPC node with QuickNode. Actually, if you are if you are a part of this Chainlink hackathon, go to Chainlink Discord server. There is a code there so that you can get. There's our highest plan at $2.99 for 3 months for free. with applying that code. So this video will be probably public, so I'm not telling the code right now. So only those who are actually hacking during this hackathon go to Discord server. I think it's one of the channels discussion or something like that. Go a couple screens up, or I will also post it after the workshop, the code to get this for 3 months for free. But also, if you don't want to do that, you can create your free account here and then start getting endpoints. So I will not go through account creation. It's just an email, like name, email, something like that. And in 60 seconds, you are going to have your RPC node. So this is what we are going to need. We'll need to have and create an endpoint for. You choose Ethereum as network, and then below you need to choose Girly as a testnet, because that's what that's where we are going to deploy it. I already have it, Ethereum Girly, and then once inside, this is what we are going to need. This code, HTTP provider. I will delete this after the workshop so that it doesn't become public, but you can get one for free. Etherscan API key, the same. I have one that is mine, but I will change it or delete it later on. And I have also created a burner wallet and added some test Ethereum there so that we can deploy it. And this is what we need to have, at least like those 3 things. If we want to deploy to mainnet, we need to have an RPC node for mainnet, and obviously have real ETH in this wallet. Actually, not test ETH, which I don't have. So there is no need to go and check that wallet right now. So we have everything that we need, all the environment variables, and now let's go with the rest. Actually, before going into this code, because we are also creating the SVGs, and this is what will live on blockchain, 100% on blockchain, not on IPFS, not anywhere, just straight on Ethereum testnet or mainnet. The images will be generated by code. This is what SVG is. And if you have never played with SVGs, there is a nice beginner tutorial, for example, here, W3 schools, SVG graphics. This is how you create, like, for example, a circle. You define the SVG, you define the circle, it has different parameters, and you can try yourself. This is a nice tool that they have that you can just play. Let's say, what do we want? 80. Let's try on this one. No, that was radius. Yeah, so radius was, yeah, let's try 20, and it's gonna be smaller. Yeah, so that's how you play. And instead of yellow, you can have red, and everything is a parameter here or variable. So that's how we can start playing. But we need to have something a little bit more complicated than just this one circle. So in order to do that, because everything is code, and this is actually like x and y, this is where you start on the scale, like x50, y50. So you start here. So this point where you start drawing your circle is at x50 and y50. So that's why we need to know all the x's and y's. That's why I created a sample image in Figma. to know all the parameters that we will need. So this is it, like width 1250. So that's what is going to be our view box, and the box for background, it will be 1250 width and height. And then we are, for example, looking at this like triple ball. It starts at x150 and y50. So this is this point where it starts, and then it has other parameters like width is 950 pixel, height is 300 pixel, and the same for all the other parameters. Like, for example, this ball is x starts at 475, y at 800. So creating everything in Figma to start with, it makes it much easier than to create in code. And now let's have a look at what we need to create. For the SVG. So this is what I start with, and I'll go quickly because we don't have a lot of time. So this is how I look at it. So first of all, a view box creating. So this is where our SVG will live. So it will 0 and 0. This is the starting point. 1250 and 1250 the end points. And now then after that, I list everything that is needed. Then a box for a background, which will be filled with background color. Then we create the first row, recreate what we have seen in Figma. The first row will be a triple ball. Then the second row will have first a double ball, then a single ball, and then 3 single balls in the third row. After we create that, we will need to create also the eyes. So, for example, the eyes here in the first row, and also animation, because as you can see, every 10 seconds, the eyes show up and then they disappear. Right about now, yeah, this is animation on top. So once we have all that, we will be ready to translate this static code into dynamic in our smart contract. So let's make it faster without going step by step. So this is this code, and let's run it, and we see that this is it, and the animation should also be here. The eyes are here. So very quickly, let's go through this. So the background, we draw a rectangle 1250 by 1250 with this color. This is light blue color. This is what we see. We can change it to black and quickly run it. Yeah, this is exactly what it is. And black is also nice with this one. Once we have that, we again, as we have seen, there is a nice function for drawing circles. And it works nicely to draw a circle like this, like a single one. But once we have like a double circle or a triple, this is no longer circle. And with that function, it's impossible to create. So what I have done is I'm not creating a circle. I'm creating a rectangle, like 3 times width. And then what I'm doing is I am adding, this is it. I am adding, and I think this was the same in Figma. This is a rectangle, and it has the corner radius at 150, which is half of the height. So we are adding the corner radius here at the top, at the bottom, and everywhere else. That's how it looks like a stretched circle, but that's actually a rectangle with large corner radius. And that's how each and every ball of art is created. It has X and Y parameters, which are here 150 by 150. And it's very easy to see from Figma. It helps rather than just trying to guess and see if everything aligns or fits. So that's why I recommend starting with Figma. So rectangle is quite easy. We have width, height, width, fill is the color. This is the green color, corner radius. And then the path is this glow, shadow, or whatever else, reflection. The path is a little bit more complicated. This path is drawing an arc, and arc has many more parameters than just a circle, because it needs to know where it starts. This the starting point, 950 by 400. Then it needs to know what's the radius of the circle that we are drawing, and then what part of that circle we are showing. So this is only like 1/4 of that third circle, maybe a little less even. And then also with 2 starting points, the arc can go either a small one or a large one. So we're also showing that we want that small arc, not the outside arc. And there's a lot for tutorials to show how the path works and so on. So I won't go into details here, but that's how you start doing. Once you start playing with it, you'll pretty quickly get a hang of it. When I started doing it, I didn't know SVG, so it took me a couple hours to maybe not be proficient, but to be able to start doing like fun things. And the last thing to do is to add animation. Animation, again, is rectangle circles, but actually like 30 by 30. So this is an eye, 30 width by 30 height. This is the eye, and what we are doing is adding the animation with attribute name fill. So we are filling with specific color, and here we are adding values. The duration is 10 seconds, and repeat count is indefinite. So it is a loop repeating indefinitely. And here, because it's 10 seconds, I have added 10 values. These are not really colors. 9 of them are colors, but all of them, like the ones with 0, 0, this is transparency. So it's 100% transparent, so that it looks like it disappears. And then after 5 seconds, the one is fully white. It's not transparent. So for the first 1, 2, 3, 4, for the first 5 seconds, it's transparent. Then for 1 second, it's white. And then for the next 4 seconds, again, it's transparent. So every 10 seconds, it shows us the eyes. So this is our code. This is what we want to make dynamic, because right now this is always the top row is a triple ball, then the second row is a double ball and a single, and then 3 singles. So we want to make it dynamic. We want to make the background dynamic and randomized. We want to draw ball sizes for each ball and for each row, and come up with something that looks more or less like this. What I also wanted to do is that each ball shouldn't have the same likelihood of being drawn. So the triple ball is much more rare. Maybe not much, but it's rare, and we can have that as a parameter, and we can control that. Is more rare than a double, and a single is the most common, which we more or less can see here that the most we have the singles. But this one is like balls of art number 11, is quite rare because it has two triple balls and 1 double. So it was a nice one. There's 2 more of these, and we can. I didn't want it to make very rare so that we had an opportunity to see it here, but it's still rare enough for us to witness it, which we will see everything in a few minutes. So now that we have created our SVG, let's code. Let's start coding. Here, yeah, we are using the latest Solidity here, because why not? Let's start with the latest and greatest. And we are also importing a few contracts for NFTs. This is NFT ERC-71. So this is what the type of NFT that we are going to create, ERC-71. We will have some access control, which is ownable. So some functions should be able to be called only by the owner of the collection. So that's what this does. Base64 is for encoding that like SVG code into bytecode. So we need to encode that, and this is console.sol. It's for outputting stuff to console for us to see. So what I want to do, and this is also one of the purposes of the workshop, is how to structure and the NFT construct and how to think of it. So first I will go through all of these functions that I have come up with and explain how I see the NFT project, like this specific project, how to build it, which building parts to think in, and what to create, how to create it, how to make it talk to each other. So that's step one. Once we have that, then it's easier. We just need to fill out all the variables, all the functions, and everything else. So first we have, even in the name of the collection, we have balls of art, and we have lots of balls. So we need to be able to store the balls somewhere, like ball instances. That's the structure. The structure is called ball, and this is where we will have all the parameters for each ball, like color, like size of the ball, where it goes in that specific NFT. Is it row 1? Is it row 3? And so on. So that's the structure of the balls. Then we need a few, not public, but public variables for each NFT collection. So let's go and fill that out right now, actually. So first is how many NFTs we want to create. So how many tokens will the collection have maximum? So let's not make it 10,000, which is what the largest collections have. Ours is a piece of art, a work of art, a masterpiece. So let's make it exclusive. Let's make it 111, for example. You can control that, choose whatever you want. Number of tokens minted. We are just launching this collection, so this is 0. Every time we are going to call a mint function, and when it goes through, we will increment this counter here. And the mint price. Because it's exclusive, so let's not make it free. But let's also not make it expensive. Let's have it at like 0.001 ETH. Maybe 3. Let's make it 0.03 Ether. And instead of going with like lots of zeros for the price, we are using this Ether keyword, which makes it much more user-friendly and readable, which is still in the background and replaced into lots of zeros for way price. Then the next, what we will need to create is a mapping to store all the SVG code for each token. So every NFT is actually like a piece of SVG code. And because everything is on chain, it's not an image stored on the server that we just show a link to and that's it. It is stored on chain, so we need to have a place where we store that code. So this will live in a mapping here, and then it will be used in the functions later on. So we have the structure, we have a mapping, so we have the big picture taken care of. Here we will write our events. So whenever something important happens, like for example, a new NFT is minted, we will emit an event, which we will declare here and then run in the mint function. After that, we need to call a constructor, which starts the smart contract when it's deployed, and we need to give it at least 2 parameters for this. We can have more, but we don't need it for this collection. The first parameter is the name of the collection, so balls of art is what we decided to call it, and then the name of the token could be anything. It's not actually used, maybe other than in Etherscan, so let's call it BART. Doesn't really matter. And next is where all the functions live. So now let's go through that table of contents for functions. Maybe I'll try to make it even larger right now. So first, like I mentioned, what we need to do is we need to have a background color random background color to start with, because we need to start filling out the NFT, and we are starting with background color. Once we have that, we need a function to pick a color for a specific ball, and then we will call that function many times for each and every ball that we need to create that NFT. Once we can have what we already have, like background color and the ball, the colors for each and every ball, we can create an instance of a ball, which will be then this structure. We will be able to create that structure with that information. Once we have a ball structure, we can start filling out the information for this structure with all the variables, which is, first, we already have the background color in ball color. What else we need is a ball size. So we need a function to draw a random ball size. It's 3, 2, or 1. The only 3 options available. Once we have all that, then we are ready to draw the full NFT, because we don't need anything else. We just need the number of the balls, the colors, and randomized all the stuff which we have done in the previous functions. So we are ready to create the SVG code for a single ball first, then a single line, combining that information. Then we add lines, we add eyes to one of the lines, and with all these pieces together, we have everything for final SVG, which we generate here. And at this point, we are ready to put it onto blockchain. For that, we are generating a token URI where the whole SVG code will live, and that's how we will put it onto blockchain. That's where it's going to live forever, or until the testnet is going to live, like Rinkeby, for example. Rest in peace. There were many beautiful collections there. I deployed some stuff that I'm proud of, which is no longer there. So yeah, if we want it to live forever, we need to put it on mainnet, which actually I think I'm going to do with this collection. I had a lot of fun writing this, so I will probably need to add a few more things, write a couple tests, and I'll put it to mainnet, and just for fun, not for, probably at even smaller price, 0.001, stuff like that. I want it to live forever. It was that fun to create. So that's the token URI function. Once we have that, we are ready to mint. We have everything that we need. We have the token URI, we have SVG code, we can mint that, and all the magic is happening here. Actually, in token URI, but once we have the token URI, we need to put it into blockchain, and that's what the mint function does. It also is taking the Ether, taking the payment, so that's an important one. An important also thing, especially if you want to deploy it into mainnet, is to not forget to write a withdraw function. Because when you have different play projects, it's easy to just forget about it, never write it, because you are never supposed to withdraw, or never plan to withdraw from it. And like the first version of this contract that I was playing with, the one that we see here, it doesn't have the withdraw function. It lives on a testnet, so I don't care about like 0.2 Ether that's in the contract. But in order to be able to get that amount as an artist, as a collection creator, we need a withdraw function, and that's a simple one, just 2 lines of code. We will see later on, but it is crucial. Otherwise, the Ether will be in the contract. You will be able to see it. You will be the owner of the contract, but you will not be able to withdraw the money. You'll be able to just look at that number on the screen, that this money is yours, this Ether is yours, but you will never get it off chain. It will forever live in your contract without the withdraw function. So kind of crucial, but often overlooked in the Play project. The last one is a just copy-pasted simple function which translates uint into string. We will be writing a lot of SVG code, which is a string, and we will be drawing different numbers, which is uint. In order to combine that, we need to translate uint into string. So that's a simple function to do just that. Copy paste it from somewhere, Stack Overflow. I use it in all the smart contracts that need that, work perfectly. So I'm including here at the end. So that's our quick overview of what we are going to write. Now we have about 20 minutes to actually write it, and then deploy it, and then mint it, and so on. So there are couple functions that are particularly interesting, so I will focus on that. The rest I will try to maybe copy paste and maybe explain quickly what they do, but without actually writing it live. So if anything is unclear, just ask questions, and I'll be happy to answer. So first, structure of the ball is quite easy. The ball needs X and Y points, so where the ball starts on the canvas, the coordinates. Then how big it's going to be, width and height. So we did single, double, or triple. Actually, the height is always 300, but this is when I played in Figma. I considered maybe having the balls like this. I played with different concepts, trying different ball sizes, which didn't look good enough. So this is the one that I settled on for simplicity, because we don't have much time, but we actually can have another parameter, for example, if the balls are going to go vertical or horizontal. But ours will only go horizontal, but we still have that height parameter here, which will always be 300. So yeah, ideally we can get rid of it unless we want it to make more complicated. Fill is the color of the ball, and random seed, and we'll see that a lot across the contract. The random seed is a seed which will be given to different functions, and that's going to be a seed for a random function, so that we pseudo-random function, because we need to be able to draw random stuff without using Chainlink oracles for simplicity, but it's very easy to add it in one function where we will be generating that seed. So I'll tell where and how. But it's used throughout the contract because that's what we do. We generate it randomly, and we need that throughout, and so we need a way to keep it. And one way to keep it is in the ball structure for each individual ball. The mapping to store SVG code is pretty straightforward. The uint will be the token ID, so it's from 1 to 111. And for that specific token ID, we will have string, which is going to be an SVG, the full SVG code of a specific NFT, like this. So the full SVG of all the balls, the background, and everything else. The events we will write later on when we need that. And now the functions. So the first is to return a background color. For this, the colors are actually inside the function, so that it is it's internal function, because nobody needs to access it from outside. Pure, because it doesn't read or write from blockchain, and returns string memory, which is returning one of the elements of this array. This is a string array of string elements, 7 of them, called background colors. So what it's going to do is returning one of the arrays, which will be, again, randomly selected in a different function and returning that color from these 7. And very similarly, the next function to select color for a ball, I did it as 2 separate functions because I didn't want to end up with an NFT where, for example, the background is the same color as one of the balls or more than one of the balls, because then it would look silly. And some colors don't play well with each other. So the background colors are very subtle colors, and like a few of them, 7 of them. And to make it more interesting, for the ball colors is the array of strings and 33 different elements. And these are more vivid and interesting colors. So doing exactly the same, just different colors, different number of elements, and returning the string at that given index. So we have now the colors. So we are happy with what we have. For the colors, now we need to create a structure for the ball that we will then be filling out as we go. So create ball structure. It needs to have an X and Y, knowing to go where it goes on the NFT, on the canvas, width and height, and also the random seed. With this, we are creating a ball instance. We are instantiating that instance of the ball structure, giving X, Y, width, and height. Fill is a random seed, modular operator. So when we return modulo 33, we are getting a random number between 1 and 32, or between 0 and 32 actually. And that's exactly what we need because we have 30 here 33 elements in the ball colors array. So here, and we are using this ball colors array. And the random seed also we are getting from the parameter for that structure. So we have the structure that then we will be able to start filling out. Now, in order to fill out, for example, width and height, what we need is to draw ball size. This is draw ball size is looks like a simple function, like maybe looks at what it needs to do. It needs to return 1, 2, or 3, but it's not that simple. It's not just like you get 1, 2, or 3 randomly. It does a few things. So first of all, if you are selecting a, let's take this one, for example. If you're selecting the size of the ball here for the first element in the first row, then all the options are available. It could be a 111, then it goes across the whole line. It could be a double, then it goes for the first 2 slots, or it could be a single like here. But if we are selecting the size for the second ball, we already cannot have like a 111 because it will not fit. So we can only have double or single here. For the last one, we don't even run that function because we only have one option, which is one single ball. So that's what we are trying to do here. First, we are assigning probabilities. Like I mentioned when showing the collection on OpenSea, we have probabilities of how often we want to see a triple, double, or single. So triple, we are assigning 20%, double, 25%, everything else is single. So if max size, which is one of the parameters of the function, is 3, then we see if that random number between 0 and 100 is less than 20. If it is, then we return 3, that it's a triple ball. Else, if it's less than 45, which is 20 plus 25 here, then it's a double. Everything else is a single one. If the max size of the ball is not 3 but 2, then we are assigning probabilities that double is 30%. Everything else is a single one. So we get either 3 or 2 from this function, but we actually are controlling how often we are getting these numbers, and we can start playing with it. But that maybe 111 is just like 1 in 100, for example. So that's a little more tricky function than just having 1, 2, or 3 returning. And then SVG code for a single ball. This is actually based, all of that is based on what we created here. Just that this is a single ball code. This is what we have for each ball, and all the elements here that they should be dynamic, like X and Y should be dynamic, width should be dynamic, fill color should be dynamic because we will be filling with different elements. Radius is the same, the radius is constant, and here the parameters for the arc are also dynamic. So that is what we are going to do here. Function SVG, ball SVG. We are just replacing all that here, and ABI in code packed is for us to be able to concatenate all the strings with taking the parameters. So this is the static code that we have seen in that in here. Rectangle, and we are replacing everything that needs to be dynamic with the instance of the ball structure that we are passing to this function. So ball.x, ball.y, ball.width, height, and so on. With this path, we are drawing a glow for this ball, and we are returning actually the this is return. And the return statement is the whole code that we need. So that's our single ball. And one of the most interesting functions in this whole smart contract is actually how to create a single line. Because like I said just a couple minutes ago, it very much depends what you have chosen here. Like, for example, we are drawing the ball for the first ball in this line. Is it triple? Then we just draw the triple one. Is it double? Then we draw double and then a single, because we don't need to draw the last element. If it's a single, then we draw a single one and then draw again to see if the second ball is double or single. So there is a lot of edge cases here, and we need to account for each and every one of them. So what we are passing is the line number, because the y parameter will depend on the line number. And we are passing the random seed, which will be how we generate the random number for each and every ball here, and every color and everything else. So first we instantiate the simple empty string, which is line SVG. And whenever we draw a ball and have an SVG code for the specific ball, we'll be concatenating that code to this line SVG, which starts out empty. So first, Y parameter, depending on the line, it's either 150 for the first line, 475 for the second, and 800 for the third. And then we are doing what I have described. If the ball size at slot 1 is 1, then we are drawing the ball size, calling the ball size function. Draw ball size function. And if it's 1, then we are creating an instance of the ball of 1, and then painting that at slot slot 1. For slot 2, we again are trying to draw ball size, and depending on ball size, if it's a double or a single, we are either just drawing the double and that's it, and that's the end of the line, or if it's a single, then we draw again. So if it's a double, so we have a double and that's it. If it's a single, we draw again. Same if the first ball in the line is a double, then it's a little simpler. We just draw a double ball and then draw a single ball after that. And that's it. And if the ball is triple, this is the simplest one. We only draw one ball, which is a triple one. We concatenate it with line SVG, just one ball, a triple one, and that's it. So there's a lot going on here. I don't want to go through everything, but that's, yeah, I explained how it works and what it does. We run this 3 times, actually, for each line, which we will see in a few minutes. That's how we generate the SVG for each specific line. After that, we need to add ice to this, because we already have our all the balls. We already have the lines drawn with the balls. Now we need to add the animation. So what it does is it chooses randomly the ice location meaning which line it's going to be, the first one, the second one, or the third one. And depending on the location, we are drawing, it depends only on Y. These are only two dynamic things here. Everything else we have seen in that SVG that we have created previously. So this is quite a lot of code, but this is quite simple, not a lot of dynamic stuff going on. Now that we have the eye, we have the background, we have all the balls. Now it's time to create the final SVG code. The final SVG code for the NFT is going to be like this. We feed 3 random seeds to this function, 1 for each row, because we don't want to run 3 rows with the same seed, because then we will get the same result and all 3 rows would be identical. So we need 3 random seeds, and that's what we will be passing from a different function. That will be from a min function. This is the beginning of the background code that we need to add. And once we have the background code, we have the ice location selected randomly, either 1, 2, or 3. And then we just run this is the first line of code that we see here. Boom, this is it. And after we have the first line of code, we add the background code. And then we generate line SVG with 3 different seeds 3 times. So we are calling this line SVG function 3 times, which generates us 3 lines. We are adding that, concatenating with the final SVG parameter, and then closing the SVG. And that's it. That gives us the final SVG code that will live on blockchain. And the way that we put it on blockchain is with the token URI function, which is part of ERC-721 protocol, but we are overriding the function, because usually what happens is, so what this function does, it creates a few things. So this is the URI for each and every NFT, and it has the name for each NFT, which is here. This is the name. So ball of art number X. It could be anything, but we are just numbering it. So we are adding the name, adding the uint to string token ID. We add description. Description is the same. This is static, and so it's the same for each and every NFT, but we can also make it dynamic and make it interesting. This is where we are adding the code here. So we are encoding and token ID to SVG. token ID. So that's where we are adding the final SVG code to this, which will live on blockchain and generate this this image, this SVG, and that's how we override the token ID, and this tells that it needs to be overridden. How we put it on chain. Now that we have an option to put it on chain, we actually need to mint it. Minting it is rather simple compared to everything else. There's a lot of code, but it's all very simple. Because minting is a public function and a payable one, it needs to check a few things first. So first of all, if the token ID, because I'm giving an option to choose a token ID. It's not like going from 1 to 111 like incrementally. You can choose whatever you want. So first we need to make sure that it's more than 0 and less than max supply, which we instantiated at the top as 111. So we make sure that the token ID is between 1 and 111. And also we make sure that the price is again dynamic. It's 003, I think. But you can pay more. I want you to play with it. Usually the price is static and you need to pay that exact price for this NFT. But for this contract, I did it like equal or more of this price. So you can pay 0.1. If you like the artist and want to pay more, you are free to do it. You pay more and you get that specific NFT, which I haven't seen anywhere in the NFT world. So yeah, wanted to play with that functionality. And now that we have that, we are generating 3 different random seeds. Because we need 3 for 1 for each row. And these are 3 different ways on how to generate pseudo random code. So it's it uses Ketchak 256 hashing function, and it takes a couple parameters. So we can play with different, but because everything on blockchain is public and visible, then everybody can see what seed is generated. So what functions are given to the function. So base fee, how much is the gas cost for or gas total actually for this specific block. Then the timestamp of specific block, or we can use timestamp and the sender, which is the address of the wallet that is minting, or sender wallet and timestamp. So 3 different ways. We don't need to use 3 like this. We can have more parameters here. We can have block number or whatever else. But this would be the place where we are running 3 functions to Chainlink Oracle. If we want truly random stuff, which is provably and verifiably random, this is where we would put it. This is a simple like play toy version of the random function, but for this project is good enough. And then once we have that, we are putting this into our mapping. So we are running generate final SVG function, which we have seen, which it needs all these random seeds and generates lines and adds eyes, adds animation, adds background color. So that the heavy lifting is done here. And once the heavy lifting is done, it returns the large string of SVG, which we are putting into our mapping, which we have defined at the top. So the mapping which translates the token ID into the SVG code for that specific ID. So that's how we are storing that SVG on chain. This will live in that mapping, and this will forever be there if we are putting this on mainnet. So it's already in the mapping, and now the last thing that we need to do is mint This is the function from ERC71, so we don't need to define it. We just run it. We need to give it two parameters: the sender, which is the address of the person minting, of the wallet minting, and the token ID, which we can choose between 1 and 111. Unless it's been already selected, then we need to choose another one. And if the token ID is not taken, then it means that the mint function was successful, so we have minted it. So that's why we are increasing the counter of total supply. It goes from 0 to 1, and we are emitting Ball's created token ID. So we haven't defined it at the top. The event, so we are doing it now. Balls created, and we are returning token ID, so that then we can show that this ID was minted and in the event. So that this is how we define the event. Event balls created, unit index token ID, and then we can access this information off chain, and it could be a trigger for automation or anything else, or a trigger for the front end. So if the emit is evented, it means that the NFT has been minted. So do something fancy on front end, like, I don't know, like something like this. We have a Fiesta. Yeah, it's live, it's minted. So we have minted it, and we have created the event and the last function. But if you are putting it on mainnet, one of the most important one, for all the hard work, you need to be able to be paid, and not just paid, but to be able to take that payment. And this is a simple function, unit balance. So this would be the whole balance address of this contract, and balance address this balance, which would be the sum of the whole ether for this. And once we have this balance, we are sending it, transferring it to the MSG sender, which with access control of only owner, we are checking if the person, the wallet calling this function, is the owner of this contract, and if it is, then we are sending the whole balance to that wallet. So that is it, and we have the contract. Now let's try and deploy it. We have the contract. We have selected everything here. We have the APIs in the env hard config. Let's see if we have hard girly. We need to uncomment girly so that we can access this testnet. And as you can see, I have this defined like mainnet as well, or Polygon testnet as well. It depends on where you want to deploy it. So we uncomment the network, the blockchain that we actually want to deploy to. We are going to do it for Girly. And once we have that, let's see if we haven't made any errors. So first, yarn hardhat compile, see if everything compiles or if we have done any errors. Looks like it looks good. Otherwise, we would have seen the error by now. It has compiled. Awesome. It created a couple of folders here with artifacts, cache, and everything else, which is going to be needed for deployment. And let's try and deploy. So we are running a script, very simple script here. So there's a deploy script. It just takes the balls of art contract and runs the deploy function. And once it's deployed, it says balls of art deployed to, and gives the address. That's it. So as simple as it gets. We are giving two parameters, the network, like actually a one parameter network, and specifying which network it's going to be. And hopefully it doesn't take too long. I tried doing it today, and the Girly network was quite busy and expensive and took a long time. Let's see how busy it is right now. Gas price 8. Nice. So it should be fast because it was about 80 when I tried it earlier today. So we are still deploying it. One important thing for it to be able to deploy, so this is that burner that I have created, that D667. So this is that. This is this wallet that I have the private key. So we need to have Ether here. This is the Girly ETH. So hopefully this is enough to deploy. Its gas price is quite cheap, so it should be fine. But we cannot deploy it from the empty wallet. We need to have Girly ETH. And if you don't have Girly ETH, it's quite easy. You go to faucetquicknode.com. You don't even need drip. You go to faucetquicknode.com. You connect the wallet, and you choose. It's multi-chain. It's not just Ethereum. Choose Ethereum, Girly. It automatically fills the wallet that you're connected with, and you click continue. I have already done it in the past 12 hours, so it doesn't let me do it, but it gives you 0.1 ETH, or if you include a tweet in it, it gives you 1 Ether. So if you don't have it, you can have it here. It takes a long time. Takes a long time to deploy, but that's actually hard compile. Deploy to Girly. This is practically the one step before last. We are deploying it, and then the last thing that we will need to do is we will need to verify the contract on Etherscan with the contract address that is going to be given by this function. But it doesn't look like it's going through. It doesn't throw any errors, so the contract is fine. It's just probably the network is busy. Okay, let's try it again. If it doesn't go through within the next minute, then we'll skip this step, unfortunately. But actually, while we are waiting, I have written a full guide, 73-point checklist on how to write a good NFT smart contract. This is not a tutorial, step-by-step tutorial how to go from 0 to deployed one, but it's a checklist to see, to check against what you have done or haven't done. And there is actually one of the points here is about with the draw function, accept payment or ETH payment or non-ETH payment. And this is the function here, function withdraw. Don't forget about that. And for each section, the preparation section, security essentials, gas savings section, you can have it as a guide or as a series of 4 videos. Just when writing an NFT smart contract, very useful to go through all the steps and check against your contract. Okay, it looks like it doesn't go through. So let's go quickly through the last step. So assuming that it goes through, what happens next is that we get the address, and then we verify on Etherscan. And the way it goes, so we'll need to work on this one. Sorry about that. So we would have this on Etherscan, and we would be able, this would be the verified contract, the green check mark. Once we have that, we can mint manually. We connect to it with the MetaMask, and we run the function that we have just written, mint balls of var. This is the, let's see, this is payable amount, Ether. So this is how much we want to pay for this. And let's pay 0.01. Token ID, let's have 77, less than 111. And right, if the network is busy, maybe it won't go through.
And Radek, just because we're kind of short on time here, and have other workshops going on.
Yeah. Okay. So that would be the last step. So the last step would be that we run this function, and then it shows a new transaction, and then a new NFT would be showing up here. It would go from 11 to 12. With the new one, it would go from 0 to 1. And the code works. The smart contract is good because it's not throwing any errors, but the network is busy. Sorry about that. I will push the code to this repository.
Yeah, that'd be great. And then, if people have questions, I think I see a couple. If you could drop the Figma maybe in the Discord.
I'll try to drop a Figma. I'll see if it's public. I will stay after the workshop is over. I will stay. I will go through all the comments. I don't know if the live chat comments will stay or disappear.
The chat won't.
I will put everything.
Yeah, if you hop into the Discord, that'll work great.
Discord as well, but the chat here in YouTube, and I will not be able to update the video description, but I will add comments as myself, answering as many questions as possible, providing links, providing answers to everything that you might have. And actually I deployed. So yeah, so it is live. It is it works. So yeah, all good. Yeah, it took 200 seconds. So it never took so long. Only when going live. Yeah, as usually.
Yeah.
So thanks a lot. I will be answering all the questions. Sorry, I didn't have time to do it live. Girly didn't want to cooperate. In the end, it did. So yeah, I'll maybe even post the link to that specific Ether scan to Ethereum address, the contract address. We did it. It took a little bit longer. We did it from 0 to live NFT collection. Thanks a lot. Sorry, it took a little bit longer. I will be in the comments replying in Discord chat. Also, hop to Discord for the $900 worth of RPC nodes for 3 months if you want. Thanks a lot. It was a pleasure.
Love it. Thank you so much, Radek. And thanks everyone who joined and participating in the chat. If you all have questions, definitely go to the Discord and hang around. We got the Protocol Labs team coming and show you how to deploy this into a decentralized service. And thank you so much, Radek. And we'll see you all soon.
Cool. Thanks a lot. Thanks. Bye, guys.